Welcome to IOQM 2025 solutions to the paper. Okay, in this Olympiad, we have already covered part 1, which is 2 marks questions. This is part 2, where we are going to cover the 3 marks questions. That is question number 11 to 20. Order may be different depending on which session you have written the exam. Let's get into the 3 marks questions. Yeah, the first one is consider a fraction a by b not equal to 3 by 4, where a comma b are positive integers and GCD of a comma b is 1. Okay, which means they are telling a by b is in its minimal form. Okay, and b is less than or equal to 15. If this fraction is chosen closest to 3 by 4 amongst the all such fractions, what is the value of a plus b? Basically, find out a by b, I mean a and b values, and then what is the a plus b value. Okay, so this looks a simple problem actually. Okay, what we need is a by b minus 3 by 4 should be minimum. Of course, the absolute value, not the subtraction, but the difference. Okay, so absolute of a by b minus 3 by 4 should be minimum. If I write it other way, it is 4a minus 3b divided by 4b. Absolute value should be minimum. Okay, and this is minimum if, okay, this is sorry, not of, if 4b is maximum and 4a minus 3b is minimum. These are the two conditions, right? So let's take, instead of taking two variables, let's consider 4b as maximum. So b can be maximum, 4b can be maximum if b is 15, right? B is less than or equal to 15. So let's consider the value 15 first. Okay. So if b equal to 15, then what happens? 4a minus 3b should be equal to, closest value should be minimum is 0, right? So closest is 0. Then 4a equal to 3b. If I substitute b equal to 15, a will become 45 by 4, which is 11.25. Since a is an integer, so nearest integer is 11. Okay. You can also take, consider 12 here. Okay. And find out 12 by 15 or 11 by 15, which is closest to 3 by 4, you can find it. Okay. But we can easily tell 11 by 25, 11 by 15 is closest to 3 by 4 than 12 by 15. Okay, so one option is a by b is 11 by 5. Okay, now let's also see different values. Okay, let's consider b value as 14. Okay, just to take another opinion maybe, right? So if b equal to 14, 4a equal to 3b, or a is equal to 3 into 14 by 4, which is 10.5. Okay, so here also you can consider 10 and 11 again and check which one is closest to 3 by 4. So out of this, 11 definitely is closest to 3 by 4. So a by b is 11 by 14. I think these two are enough for us to tell which one is closest to 3 by 4. Others will be far from 3 by 4. Okay. So 11 by 15 is around 0.733. 11 by 14 is around 0.7857. If I subtract, check the difference with 3 by 4, 11 by 15 is closest to the 3 by 4. That is 0.0167 is the difference. Okay. So the answer is a by b is equal to 11 by 15 and a plus b equal to 26. That is the answer. Okay. Yeah, this should be, if you are practicing Olympiad, this should be an easy problem for you. Next. Consider 5-digit positive integers of the form ABCAB. Okay, ABCAB bar is written. That means they are the digits. Okay, ABC are the digits. Are divisible by 2-digit number AB. Okay, but not divisible by 13. What is the largest possible sum of digits of such number? Okay, so yeah, let's look at it. This is a interesting problem. ABCAB, I can write it as AB times 1000 because they are after 1000 units, right? 1000 digits. Okay, so plus C times 100. Okay, plus AB. Okay, AB times 1, basically that is AB. So I can also summarize this as AB times 1001 plus 100 times C. Okay, AB times 1001 plus 100 times C, and 1001 I can actually make it into factors where 13 is one of the factor. Okay, so now this whole problem gets into a simple form of modulus or congruency. We can write it as ABCAB congruent to 0 mod AB, means it should be divisible by AB, and which means AB times 1001, right? AB times 1001 plus 100 times C should be congruent to 0 mod AB. Okay, which means since we know that first part is divisible, so only the second part should be divisible. So 100 times C should be congruent to 0 mod AB. Okay, so this is the condition for us, one condition. And second condition is ABCAB, okay, should get Y, sorry, you can write it as Y here. Okay, Y mod 13. Okay, which means AB times 1001 plus 100 times C should be congruent to Y. This is Y mod 13. Okay. What is the meaning of this one? We know that this one is divisible by 13 already. Correct? This is divisible by 13 already. So I am looking at 100 times C should not be divisible by 13. So 100 times C congruent to Y mod 13, where Y is not equal to 0, means 100C should not be divisible by 13. So these are my two conditions which I need to solve the problem, right? One is 100C congruency to 0 mod AB, means should be divisible by AB, and 100C should not be divisible by 13. Okay. Now he is asking the maximum possible sum of the digits. So let's take C as the maximum value and C. Okay. 100 times C can be any of 100, 200, 300 up to 900. Correct. C can be only those values. Now if I take C is equal to 9, which is maximum value. Okay. So let us consider C as 9. Now 900 is not divisible by 13, and 900 is should be divisible by AB, right? So 900 is congruent to 0 mod AB. So what are the options for me? AB should be what should be the options for AB? AB should be 25, 50 and 75. These three numbers divide 900. Okay. So out of this, which one is the going to give us highest sum of digits? 75 is obviously going to give us highest sum of digits, right? So 7 plus 5 is 12, which is the maximum value. So my ABCAB, okay, any other value you can try, it won't give you maximum in total. So ABCAB is nothing but 75975 or 75,975. This is the number I am looking at it. So sum of all the digits is nothing but 33. That's the answer. Okay. Yeah, this is a moderate question, definitely. Yeah. Next. Three sides of a quadrilateral are A equal to 4 square root of 3, B equal to 9, C equal to square root of 3. The sides A and B enclose an angle of 30 degrees and the side BC enclose an angle of 90 degrees. If the acute angle between the diagonals is x degrees, what is the value of x? Okay. So yeah, this is a very good problem. You can solve it very easily using coordinate geometry if you are good at. Only thing is you should get the idea of solving using coordinate geometry. Okay. You can solve it other way, it will become moderate. But once you get the idea of coordinate geometry, this is easy actually. Uh, Otherwise it's moderate. So I'll call this as moderate because very few people will solve it using coordinate geometry. Okay. So this is what the given information is. Okay. There are three sides information is given ABC. Okay. And two angles are given between those lines. Okay. Now my AB is 9, BC is root 3, AD is 4 root 3, and angle between AD and AB is 30 degrees. Angle between AB and BC is 90 degrees. This is the given information. The diagonals are in the orange or red color here. We need to find out angle between these two, whichever is the acute angle we need to find out. Okay. So let's consider A as origin. Okay. A as origin, which means 0, 0. And AB will become 9, 0. And because AB is the x-axis now. Okay. If A is origin, B is 9 units away from origin, which is on the x-axis, which is 9, 0. Okay. And C will become 9, square root of 3 because it is at the height of square root of 3 at x equal to 9. Correct. And D also we can get it. So once we get all four, it is very simple problem. Let's see how to get D also. So my A is 0, 0, B is 9, 0, C is 9, root 3. Now D, how to get D? D, if I draw a circle with AD as radius, okay, with AD as radius, that is 4 root 3 as radius, then D coordinates are nothing but 4 root 3 cos theta, 4 root 3 sin theta, right? So I will write it. My D is nothing but 4 root 3 cos theta, 4 root 3 sin theta. Now we know theta is 30 degrees, which is given because AD makes an angle of 30 degrees with AB, correct? So D is nothing but, if I substitute 30 degrees in this cos theta sin theta, I'll get D as 6, 2 root 3. These are the values. Now I have 4 coordinates. So now I can do whatever I want actually, right? So first is slope of AC, one of the diagonal, M1 I will call it, which is nothing but AC I have coordinates, right? 0, 0 and 9, root 3. So root 3 minus 0 divided by 9 minus 0, which is root 3 by 9. This is my slope of AC, okay, M1. M2 is slope of BD, which is nothing but 6, 2 root 3 and 9, 0 slope, which is 2 root 3 minus 0 divided by 6 minus 9, which is minus 3. So BD is equal to minus of 2 root 3 by 3. This is my M2. Now I have M1 and M2. Okay, so angle between AC and BD is nothing but tan alpha is M1 minus M2 divided by 1 plus M1 M2. Since we are looking at acute angle, I'll take the positive value of it one. Okay, so if I simplify, I'll get tan alpha equal to square root of 3. So which means acute angle alpha between the diagonals is 60 degrees. That's the answer. Okay, this is easy if you solve using coordinate geometry. Yeah, otherwise it's moderate. Yeah. Next. Yeah, next one is a function f is defined on the set of integers such that for any two integers m and n, f of mn plus 1 equal to f of m into f of n minus f of n minus m plus 2. This is the definition of f of mn plus 1 holds and f of 0 equal to 1, which is given information, one value. Determine the largest positive integer n such that sigma k equal to 1 to n f of k is less than 100. Okay, which means f of 1 plus f of 2 plus f of 3 up to f of n should be less than 100. So for this problem, first thing is we should define f of k or f of x, whatever. Okay, once we define it, we'll get the values. Or otherwise, find out the values of f of 1, f of 2, f of 3 up to some values and see if they are coming close to 100. Right? So let's read. This is the given definition. So if I take m equal to n equal to zeros, then I will get f of 1 value. Okay. So because only f of 0 value is given. So I have to take m equal to n equal to 0. Okay. So f of 1 is nothing but f of 0 into f of 0 minus f of 0 minus 0 plus 2, which is 2. F of 1 is defined as 2. Now I have my f of 0, f of 1. Let's see what is f of 2. Okay. For f of 2, I can make a common statement. Always I want to keep m equal to 1 and increase n. That's it. Okay. So m equal to 1 and n equal to 1. Okay, which means f of 2 is nothing but f of 1 into f of 1 minus f of 1 minus 1 plus 2, which is 3. Okay, looks like it is an increasing function, just a plus 1 function, x plus f of x equal to x plus 1. Now for 4, okay, m equal to 1 I want to keep it constant and n equal to 2. Then f of 3 I get, which is nothing but 4. Okay, so which means it is very simple. F of x equal to, okay, since m is always 1, m is always 1 and n is x, correct? So n equal to x minus 1, sorry. Okay, then f of x is defined as f of 1 into f of x minus 1 minus f of x minus 1 minus 1 plus 2, which is nothing but f of x minus 1 plus 2. Okay, this is a recursive function, just sum of the previous plus 1 of the previous function value. Okay, so this is so simple now. Now what all I wanted is sigma value. Okay, so sigma is nothing but f of 1 plus f of 2 up to f of n, which is nothing but 2 plus 3 plus 4. Everything is starting with 2, right? F of 1 is 2. 2 plus 3 plus 4 up to n plus 1. Okay, remember this is n plus 1, should be less than 100. What is the sum of all this one? You can use n into n plus 1 by 2, and here maximum number is n plus 1. So n plus 1 into n plus 2 by 2. 1 is not there, so minus 1 you can do. So n plus 1 into n plus 2 divided by 2 minus 1, which is less than 100 should be. So now you just cross check where you will get close to 100. At n equal to 12, I get 90 total. Okay, on the LHS side, which is less than 100. Okay, at n equal to 13, I get 104, which is greater than 100. So obviously n should be equal to 12. Okay, so this is my answer. I think this is a moderate problem. Next. There are 6 coupons numbered 1 to 6 and 6 envelopes also numbered 1 to 6. The first 2 coupons are placed together in any one envelope. Similarly, the third and the fourth are placed together in different envelope. The last 2 also placed together at another envelope. How many ways you can do this if no coupon is placed in the envelope having same number as the coupon number? Okay. So first thing is understand the problem carefully. Okay. There are 6 coupons 1, 2, 3, 4, 5, 6, and they are grouped into 2 pack of 2. 1 comma 2 is 1, 3 comma 4 is 1, 5 comma 6 is other one. Now I also have envelopes, 6 envelopes 1, 2, 3, 4, 5, 6. I have 6 envelopes also. Now 1 comma 2 cannot be placed in 1 and 2 envelope. 3 comma 4 cannot be placed in 3 and 4 envelopes. 5 comma 6 cannot be placed in 5 and 6 envelopes. And one more thing is 1 comma 2 are together placed in one envelope, not individually one different ones. Okay, so this is a simple permutations and combinations problem, right? Very easy. We should just take the permutations properly. Okay, so let's draw one simple tree to understand this. Let's say 1 comma 2 goes into 3 comma 4 because 1 comma 2 cannot go into 1 and 2, correct? It can go either 3 comma 4 or 5 comma 6. Let's assume it is going to 3 comma 4. Okay, it is going to either 3 or 4, two options, right? Then I have two options left. Now 3 comma 4 coupons can go to either 1 comma 2 or 5 comma 6. Correct? Two options here also. Now I am left with 5 comma 6 now. 5 comma 6 can go to 1 or 2 because one of them is taken out by 3 comma 4 coupons, or 3 comma 4, one of them is taken by 1 comma 2. So there are two options here, either 1 or 2 or 3 or 4, right? Similarly, if 3 comma 4 goes into 5 comma 6, I am left with 5 comma 6 has the options of 1 comma 2 comma 3 or 4. Okay, because one of them is taken. Okay, 1 comma 2 both are free, but 3 or 4 only one is left, so three options are here. Okay, now I know that this is a simple tree, but it looks like how to understand this one is, whenever you come down it is multiplication, whenever you have two options it is addition of these two. Okay, so which is very simple. Okay, subtotal with 1 comma 2 going into 3 comma 4 is 2 times, okay, because here two options I have, 2 times 2 into 2, two options here, 2 options here, 2 into 2, plus, because there are two options here, right, plus 2 into 3, right? So which is nothing but 4 plus 6, 10, 10 into 2, 20. 20 is the subtotal if 1 comma 2 goes into 3 comma 4. Similarly, 1 comma 2 can also go into 5 comma 6. I'll get exactly same thing, same set of values again, right? So in that case, if 1 comma 2 goes to 5 comma 6, I again get 20 options. So total number of options are, total number of ways I can place the coupons in envelopes is 20 plus 20, that is 40. That's the answer. Hope you understand this. This is definitely easy to moderate. Yeah, I just place moderate because I am looking at 8th and 9th students also. Yeah, next. Let f of x and g of x be two polynomials of degree 2 such that f of minus 2 divided by g of minus 2 equal to f of 3 divided by g of 3, which is equal to 4. If g of 5, f of 7, g of 7 are given, what is the value of f of 5? Okay, so this is also another function problem where you have to find out the main function and then simply solve it. Okay, but you look at this one, f of minus 2 by g of minus 2 equal to 4, f of 3 divided by g of 3 also 4. So f of 2 is equal to f of 2 minus 4 times g of minus 2 is equal to 0. F of 3 are correct. F of 3 minus 4 times g of 3 also equal to 0. Correct. So if I consider a function h of x, okay, which is a polynomial in terms of f of x and g of x, how it looks? It looks something like this. H of x equal to f of x minus 4 times g of x. Okay. How did I get this one? From here only. I just got it from here. Okay. If I consider this as f of x, g of x, f of x minus 4 times g of x equal to 0. That's what I got it. If this is my polynomial, and since f and g both are polynomial of degree 2, that is quadratic polynomials, right? H of x also will be quadratic polynomial. Correct? Now, h of x has two zeros. One is h of minus 2. H of minus 2 equal to 0, because that is how we derived it, right? F of minus 2 minus 4 times g of minus 2 equal to 0. Also h of 3. So h of x has two zeros, minus 2 and 3. Okay. It's a quadratic polynomial. So only it can have maximum two zeros only. So h of x, I can write it as k times x plus 2 times x minus 3. Correct? K times x plus 2 times x minus 3. Why k times? Because this is a polynomial. We need to identify what is the value of k. This is nothing but f of x minus 4 times g of x. Now, how to get this value of k? Whether k is 1, 2, 3, what is the value? So, for that one, I am already given extra information here. F of 7, g of 7 is given. So, substitute what is the value of h of 7, right? For x equal to 7, h of 7 equal to k times 9 times 4 equal to, okay, f of 7 is 12 minus 4 times g of 7 is 4 times minus 6. So overall I will get k equal to 1. Okay, this is also 36 and 36. Okay, so k is equal to 1. This is my k value. That means my h of x is nothing but f of x minus 4 times g of x, which is nothing but x plus 2 into x minus 3. Now I just need to get f of 5 value. So just substitute here 5 value. Correct? H of 5 equal to f of 5 minus 4 times g of 5, which is equal to 7 times 2. Okay, and g of 5 is already given 2. So my f of 5 is nothing but 22. This is the answer of f of 5. Okay. Hope you understand. This is also another function problem. Fairly simple for a 10th class or 11th and 12th students. Yeah, but a little bit moderate for 8th and 9th students. Yeah. Next.
MTA is a parallelogram of area 40 by 41 square units such that mi equal to 1 by mt. If d is the least possible length of the diagonal ma and d square equal to a by b, okay, where a by b are in their simplest form, then find the value of absolute a minus b, that is the difference of a and b. Okay, so first thing is draw the diagram. You will understand everything easily. This is my MTAI. Okay, let's call mi as x, then mt will be 1 by x, correct, because mi equal to 1 by mt. Okay, now let's call this angle theta. Okay, this is the theta. Now what I want is this d should be d square should be minimum, or d should be the minimum value basically. Okay, value of this d square, okay, in terms of in a real number, in the form of a real number, then what is that ab. Okay, that's all. Okay, so let's do MTI area is given 40 by 41, which is nothing but MT into TA sine theta, correct? MT into TA sine theta is nothing but area of the parallelogram, which is equal to x into 1 by x sine theta, which is 40 by 41. Okay, so my sine theta is equal to 40 by 41, correct? If sine theta is 40 by 41, my cos theta is 9 by 41. I can just apply Pythagoras triangle and I can find out. Okay, then in triangle MTA, okay, in triangle MTA, you apply triangle cos theta rule, which is nothing but a square plus b square minus c square by 2ab, okay, which is nothing but x square plus 1 by x square minus d square divided by 2x 1 by x, okay, which is equal to 9 by 14, because cos theta is 1 by 9 by 41, we already know. So this is 9 by 41. Okay, now if I simplify this, x and 1 by x cancels here, correct? So this will become 2 will go to other side, it will become 18 by 41 equal to x square plus 1 by x square minus d square. Okay, or my d square is nothing but x square plus 1 by x square minus 18 by 41. Now I know the minimum value of this one, this expression from arithmetic mean greater than or equal to geometric mean rule. This minimum value of this one is 2, correct? So my d square minimum value is 2 minus 18 by 41, which is 64 by 41, and their GCD is 1, so they are in the simple form, simplest form. So this is nothing but my a by b. A by b equal to 16 by 41. So difference of a minus b is 23. That's the answer. Yeah. Hope you understand this. This is a simple to moderate problem. Okay. Next. Let n be the number of 9-digit integers that can be obtained by permitting the digits 2233344444. Okay, which are 9 digits basically, and which have at least one 3 to the right of the rightmost occurrence of 4. What is the remainder when n is divided by 100? First is find out n, how many ways you can arrange them with the given condition. Once you know that number of ways you can arrange, then we just need the remainder or last 2 digits basically. Okay, so first thing is the condition is given for placeholder of 3 and 4. So let's see how many ways that can be possible. There are 4 4s and 3 3s, that is 7 digits are there, correct? So out of 7 digits, if I only consider these 7 digits, how many ways I can arrange them? 3 should be, 1 3 should be the rightmost, correct? That is fixed, and the other things can be repeated, that is 4 4s and 2 3s can be anywhere. And how many ways you can arrange that? We know already from permutation. 6 factorial, because 4 plus 4 fours and 2 threes are 6 digits. 6 digits can be arranged in 6 factorial ways. Since there is a repetition of 4 fours divided by 4 factorial, repetition of 2 threes, so divided by 2 factorial, which is 15 number of ways. Now these are the 7 digits arranged. Now I am left with the 2 twos. These 2 twos can be arranged anywhere in between these front and back. So total 9 locations I will have with the 7 digits, correct? In between and the beginning and ending. So in the 9 locations, anywhere I can keep these 2 twos. Okay, there is no rule for this one. So that can be arranged in 9C2 ways. Okay, so 9C2 is nothing but 9 times 8 by 2, which is 36 ways. So total number of arrangements is 15 times 36, which is 540. Now I need last 2 digits. Remainder when n is divided by 100, which is 40. That is the answer. I think this is definitely easy for a 3 marks question. Yeah, next. Yeah, this problem is more of drawing the right picture and putting the right values actually. So first thing is I'll explain the problem along with the diagram. Okay, so in a triangle ABC, you have a ABC here. Okay, B is 90 degrees, this is 90 degrees, AB equal to 1, this is 1, BC is 2. Okay, on the side BC there are 2 points D and E. Okay, such that E lies between C and D, means E is close to C than D. Okay, E and D. Okay, then DEFG is a square. DEFG is a square such that F lies on AC. Okay, and where is G? G lies on a circle through B with center A, which means if you draw a circle with center A and AB as radius, okay, G lies on this circle. Okay, so this is what it's trying to tell. Okay, now if the area of DEFG, that is this small square here, is m by n, where m and n are in it, m by n is in its simple form, then what is the value of m plus n? Okay, so looking at this picture, then finding out area of square is looks very difficult. But once you draw this correct picture, it is very easy. I just need to extend this picture with two more lines. Okay, these are the two lines. One is I am dropping down from EG to this value, okay, H, okay, and I am joining AG. Now what is AG? AG and AB are same, correct, because they are the radius of the circle, AG and AB. So since AB is equal to 1, AG also 1. Okay, remember this. Now what are the other values? If I call BH as x, why I am calling this as x? Because I need finally x square. This is the square area I am interested in. So if DG is x, ED also x, okay, BH also x, because this is a perpendicular which is dropped down. Okay, this is 1 minus x. And what is the value of the CE? CE is nothing but 2 minus x, and let's call this y, then minus y it is. Correct? If you call dB as y, then CE is nothing but 2 minus x minus y. Okay, now we have all the values, required values here. I need to derive two equations in x and y, then I can solve those, right? So one equation I can see here, this is a right angle triangle. I have all three values. AG is 1, GH is y, this is 1 minus x. Apply Pythagoras theorem, I get one equation already, correct? In AGH, 1 minus x whole square plus y square equal to 1. This is by Pythagoras theorem, right? Next, CEF, the triangle CEF and triangle CBA are similar triangles, correct, because this is a right angle triangle, both are right angle triangles. So and it is the line parallel to this one of the sides, so they will be similar triangles, right? So CE by CB equal to EF by BA, right? So I now have the values of this one. CE is nothing but 2 minus x minus y divided by CB is 2, okay, which is equal to EF. EF is x, AB or BA is 1. So now I have second equation. Now I have two equations and two variables to solve. That's it. Very simple. This is my simplified equation to y equal to 2 minus 3x. If I substitute it in the first equation, I'll get 1 minus x whole square plus 2 minus 3x whole square equal to 1. Simplified, I'll get 5x square minus 7x plus 2 equal to 0. I can factorize it easily. X plus 1 into 5x minus 2 equal to 0, or x equal to 2 by 5. X equal to minus 1 is not a solution because length cannot be negative, right? So x equal to 2 by 5. So I am looking interested in the area of the small square, which is x square. X square is 4 by 25. Now this is my m by n. So m plus n is nothing but 29. Okay. So problem looks very simple once you draw the right diagram and understand what is that crux of this problem, right? But it's definitely a hard problem. Yes. Next, let f be the function defined by f of n equal to remainder when n to the power of n is divided by 7 for all positive integers n. Find the smallest positive integer t such that f of n plus t equal to f of n for all positive integers n. So f of n plus t should be equal to f of n, which means n plus t should be, f of n plus t should give same remainder as f of n when you divide with 7. That's the question, right? The question is n plus t whole to the power of n plus t congruent to n to the power of n mod 7. Both these numbers, n plus t whole to the power of n plus t and n to the power of n, should give same remainder when you divide with 7. This is the problem. Okay, and now find out all possible n's, smallest positive t, which can satisfy this equation, right? Now first thing is, let's check for n equal to 7. What happens if n equal to 7? Okay, 7 plus t whole to the power of 7 plus t congruent to 7 to the power of 7 mod 7, which is 7 to the power of 7 mod 7 is, we know it's nothing but 0, right? We get 0 mod 7. So if you look at 7 plus t whole to the power of 7 plus t, you have 7 term in every expansion of it one except one last term, right? Except last term is nothing but t to the power of 7 plus t. So t to the power of 7 plus t also should be divisible by 7, correct? T to the power of 7 plus t congruent to 0 mod 7 divisible by 7, which means t should be a multiple of 7, right? So t should be equal to 7k in the form of 7k. This is my first condition of t. Okay, next let's again consider this one. Okay, if I expand this one binomial, okay, every term in this expansion has t term, correct? T term is in every one of it except n to the power of n plus t, correct? Only the first term n to the power of n plus t don't have a t term, otherwise rest all have t terms. And if you have a t term, since t is in the form of 7k, they are all divisible by 7, correct? So I am interested only in the n to the power of n plus t. So n to the power of n plus t is congruent to n to the power of n mod 7. This should be this is what we should solve now. Simplified problem. Okay. Now first check for n equal to 7. This satisfies or not. Uh, this is nothing but n to the power of n into n to the power of t congruent to n to the power of n mod 7. N equal to 7 satisfies this. Okay. If n equal to 7, this is satisfied. Okay. For n equal to n is not equal to 7, what happens? Okay. For n is not equal to 7. Okay. I can definitely cancel n to the power of n on both sides. So I get n to the power of t as congruent to 1 mod 7. Okay, n to the power of t is congruent to 1 mod 7, then it will satisfy, the given conditions are satisfied. So n to the power of t congruent to 1 mod 7 is my underlying condition, right? So we have to know here Fermat's little theorem, which states that a to the power of p minus 1 is congruent to 1 mod p. Okay, you can find out the proof of this one. This is a very important formula to remember for at least 11th and 12th students. Okay, so a to the power of p minus 1 equal to congruent to 1 mod p. Okay, if you divide a to the power of p minus 1 with p, you will get remainder 1. That's what it says. Okay, so now if I compare with the above one, okay, it is very simple. T is equal to 7 minus 1 I can write, correct? Then t equal to 7 minus 1 or multiple of it, correct? If I compare with this, because p is 7, so t should be in the form of p minus 1, so 7 minus 1, so t should be in the should be a multiple of 6. So now I have two conditions for t. One is it should be multiple of 7, other one is multiple of 6. So overall t should be a multiple of 42, correct? Multiple of both 7 and 6, because both are co-primes. Now that means t should be a 42k in the form of 42k. So minimum value of t is 42. If k equal to 1, if I take, the minimum value of t is 1, 42, sorry, right? So this is my minimum value of t. That's the answer. Okay, I am sure this is hard for anybody, and you should really know remainder theorem very well. This is one of the excellent question to understand the remainder theorem rules. Actually, most of the rules are applicable here, right? Yeah, this is hard. So that's all the 10 questions of 3 marks questions. In the next video, we'll see 5 marks questions. Okay. Till then, keep doing maths, practice more. Olympiad and JEE, all exams are same actually. These are all basic fundamentals of maths. Okay. If you are good in Olympiad, you will definitely be good in JEE and other entrance exams. Thank you.